Hello friends, in this video I am going to describe the primitive operations which are performed on a queue, that is the addition operation and the deletion operation, how elements are added to the queue and how elements are deleted from a queue. So these are the two basic operations or primitive operations which are to be taken into consideration while we are going to discuss the topic queue. So first I am going to show you a function which a C function rather, which shows you which will be able to show you how to add elements to a queue, to an existing queue containing, it may contain one element, it may contain multiple elements. So how can we add elements to a queue is our topic of discussion in the first instance, and then I will get on with the deletion operation. And for that, first we have to declare, or we have to define the structure of the queue as a user defined structure, that is as a user defined data type, or rather that is as we have taken in the case of stack, that we have taken an array and we have taken a top integer variable in the case of the stack. And in this case likewise we will declare a structure, will define a structure which will contain an array. One integer variable will be front and another integer variable will be rear. So let's get started with writing the structure of the queue data structure. Like this, I will first write type def struct queue, excuse me. Suppose I am taking an array int a1000 and two integer variables int front comma rear, closing brace, and then write queue. So this is the structure declaration, this is the structure definition of the queue data structure, that is type def struct queue int a1000 means we are taking an integer array containing 1000 positions, 1000 contiguous memory locations, and two other integer variables front and rear, and renamed it as queue. So this this will help us to go on or get on with the operations to be performed on the queue. That is, first we are going to discuss the add operation, that is the addition to the queue. So if we see like this, if we imagine a queue to be like this, and we think the queue to be ending in this position, suppose this is a 1000 element array, 0, 1, 2, 3, there are several other positions in between which I have skipped, and this is the 999 position. So in this array, in this queue, if we have all the places filled up to the last position, there will be no room for addition of any new element from behind, because once the element will be added to the queue, it will always follow the real world discipline of adding itself to the end of the queue. So in this end of the queue, we are seeing that it is full, a queue full condition we have denoted in this example. It is full from the first to the last, but we will just consider the last position, because we are to add the element from the last position, and if the last position holds some value, we are unable to insert any value into the queue from the last position. So in that case, the operation of addition will be a failure operation, and in that case we will follow a similar concept which we have used in the previous videos where I have explained the stack. That is, for the failure operation I have returned a value of 0 to the calling module of the function, and for the successful operation we are going to return 1. So let's write the function of addition. Suppose let me write this function. Suppose I am writing this function like this. Says queue int add. I am writing the function name to be add, returning a value of integer data type int add, an item which is to be inserted into the queue let it be int a, and another pointer variable q star q, just as we have taken in the case of stack as stack star s. This is a similar pointer to a user defined data type which we have defined over here. That is, the data type is q, which is a user defined data type, and the pointer small q is a pointer variable which points to the data type q. So this q can point to any variable of the q data type, of the capital Q. Q starting with the caps lock, there is the init cap q is the data type, and small q is the pointer to any variable of the init cap q data type. So now I will first see whether we can add an element to the queue. If the queue is full, then we cannot add. So I have to check that condition by writing like this: if see this, the front of this queue is here, the front is how much? 1 less than the index of the beginning of the queue, that is -1. What is rear over here? Rear is 999. So if q arrow rear equals 999, then we will print q is full, or whatever you can think of writing, like addition is impossible, q overflow, anything you can write of your choice. I am writing it in a simple way: q is full. Then we will return 0 to denote that the operation is a failure operation. And if this condition doesn't hold, we will just add the element by this sort of operation. Let me just discuss this operation a bit, otherwise you will not get to understand what I will write in the code. So suppose this queue is like this: 0, 1, 2, 3. Suppose there are 5, 3, 2. So these are 3 elements which are in the queue. So now our addition concept is always from the rear end of the queue. So in this case, front is -1 and rear is 2. So in this case, if you want to add, it can be up to 1000, it can be up to 999. So this is this sort of a queue containing 1000 contiguous memory locations. So in this case, if we are going to add this A to the rear, what we will do? First, we have to increment this rear before the addition, and the rear will become 3. After that, I will insert the element which is to be added. In this case, it is A. Suppose A is equal to 10 and we are going to insert 10 in the queue. So we have to increase the rear by unity so that rear becomes 3, so that rear denotes this position. We will create a space over here, then insert 10 over here, and in that case the operation becomes successful. So let me write that code. This is quite similar to pushing of data in a stack, where we added an element or pushed an element to the stack by pre-incrementing the top variable by 1. Here we are doing a similar operation of pre-incrementing the rear and then inserting whatever is to be inserted into the queue. So let's write that in a, so friends, as there is a paucity of space over here, I am just going, excuse me, so that I can just write the line of code on this side. So you will just consider whatever I will write over here is to be after this brace. So let me write the insertion code of the insertion. So we'll write like this. Suppose I am just demarcating with a line, and we'll write like this: Q A plus plus Q rear then third bracket, closing third bracket, and then we will insert A. So this is the operation which we are going to perform while we are adding the element from the rear end to the queue. See this QA means that is the array, that is this array, and this plus plus before Q rear means we are incrementing the rear before the addition of the element A, and after that pre-increment operation we are going to assign the item, data item A into the Q rear position, the updated Q rear position. So this is the code of the addition portion of this function, and now since this is a successful operation, we are definitely going to return 1 from the function. So this is the explanation of the primitive operation of addition in a Q data structure. So if you have any doubts and queries relating to this addition operation which I have discussed in this video, you can well post your comments and doubts in the comment section below so that I can address them. Thanks for watching this video.